Okay, let's look at this one here. This one's an interesting one. Because we know that it's non-monic, right? We know that there's a number in front of that x squared there. So I want to think about how can I actually factorize it? I want to think about how can I actually factorize it. Again, let's try my first one. Can I take out a common factor? Is there anything that's in common here?
1.
I could take out a 1. Not entirely helpful though, because it's actually not going to help me factorize. If I take out a factor of 1, I'm just going to have the same thing, aren't I? Right? It's a good point, but it doesn't actually help me in this case. I actually need to use a slightly different method. And here are the steps. They may seem a bit long here, okay? But hopefully, there is a lot of algebra involved, but hopefully you'll be more comfortable with the steps as you practice it, okay? So here are the steps I want to use. I firstly want to use the normal Psf method, but for the product, instead of just looking at that last number there, I want to look at A times C. So I want to look at whatever the number in front of x squared is, multiplied by C, okay? So that's my first step. The second step is, I'm going to break up the middle term into those factors that I find. And then the last step is I'm going to use my grouping in pairs method. Okay, so a few steps going on there, and just as a disclaimer, there's going to be quite a bit of algebra in this one. Hopefully though, as you practice, you become more confident with it, okay? So remember, always think about the goal of these questions. I want to be able to factorize it, which means I want to be able to put them into brackets. Okay? And I look at this one, I know that I can't take out a common factor. We know that that first one's not going to work. I can't take out a common factor. But then that's when I want to go to this part of my steps, and I say, I want to go down this track now. I want to first use Psf, but I want to consider A times C. So I want to look at the number in front of x squared, and I look at this number here, I want to multiply those two together. So my product, it's going to be 2. My sum, that still stays the same. That's just the number that's in the middle, that's still 3. Now my factors. Okay, what are my factors going to be? 2 numbers that multiply to 2 and add to 3. What would that be? 2 and 1, yeah. I want 2, so using my normal Psf method, right? I want 2 numbers that multiply to 2 and add to 3. That's just 2 and 1. Now, instead of skipping straight to putting them into brackets, my second step is slightly different. I actually want to break up the middle term into these 2 factors here. Okay? And it seems a bit strange why I want to do that, but it's going to help us factorize it. Okay? I'm going to break it up into 2x plus x plus 1. Okay? So let me just show you what I did there. All I did was I said, this 3x here, I'm going to break it up into my 2 factors. 2x and a single factor of x. Okay? Notice how I haven't changed anything, right? I could put these back together as 3x, but I've chosen to break this up because it's going to help me factorize them by using my last one, the grouping in pairs method. Because remember, the grouping in pairs method helps me when I have 4 terms there. Joel, can you remind me, how do I factorize by grouping in pairs again?
Find what's in common.
With the first 2, yep. And I look at them as pairs, just like that, right? So I look at what's in common between these ones. I can see that there's a factor of 2x. And remember, when you're taking out a factor, you're dividing. So here I'm going to get left with x. What am I going to get left with this term? If I take 2x out of that, I just get left with 1, right? Yeah. And then here, what's in common between this one? Just 1. So this is what Lucas was going back to. Sometimes it is helpful to take out a factor of 1. Because if I take out a factor of 1 from this one, right, x plus 1, notice how I've got my grouping in pairs situation now. I see what's in common between all these terms here. I can see there's a factor of x plus 1 that's common, right? And so my last step, step 3, is to use that grouping in pairs method. I'll factorize that out. So I get x plus 1, 2x plus 1. So those 3 steps there. I used my normal Psf method, but I considered 2 times 1 this time. I used the sum there to break up that middle one. And then I use my grouping in pairs method to factorize it out. Now commonly they'll put this bracket in front of that one in the answers. That's just by convention. So you may often see the answers rewrite it like this. Rewritten like that. And both are correct, remember, because the order of multiplication doesn't really matter, okay, in this case. So just make a note of that in your answers. Okay. So again, with my Psf method, I want to consider now not just the last term, but I want to consider the multiplication of these. So that's 3 times 3, which is 9. I want them to sum to 10. And then I want to think about my factors. Yeah, what things multiply to 9, add to 10? 9 and 1, right? Okay. So that's my first step. Use my Psf method, right? My second step, I want to break up this middle term. So I'm not changing it, I'm just breaking it up, right? So I'm going to get 3x squared plus whatever my factors were, 9x plus just x. Yep. And then, cool, I've got 4 terms now. Anytime I've got 4 terms, I want to think about grouping in pairs. So that's going to be what's in common between these first two, 3x, yeah. And I get left with x plus 3. I mean, we can check that really easily just by expanding it out again. And in this last one, again, I've only got 1 that's in common. That's just x plus 3. And then this is your grouping in pairs as well, right? That's part of the grouping in pairs. I'm going to factorize that x plus 3 out because it's all in common. And yeah, that's the answer. And again, like I said, they commonly write it with the 3x plus 1 in the front like that. Okay. Yep, questions?
For 6, why wouldn't the product be 3? Yeah, that's what I just said.
For 6, sorry?
The one that you just did, why wouldn't the product be 3?
Yeah, so with this non-monic version, I have to change it slightly.
Okay.
Because there's something, technically what you're doing with your previous ones is you're actually looking at A times C, but it's always been 1 before. So it hasn't really mattered. But now with when we have non-monic examples, for the product, we want to consider the product of the first and the last one.
So the other ones, they didn't have a number.
So, yeah, so it didn't affect anything. It was just 1 times that. Yeah.
Wait, so does monic mean 1?
Yes.
It means
Just
not 1.
non-monic means not 1. Yeah. So monic, think about like monocycle. No, it's unicycle, isn't it? There's definitely things that say mono, like
Monotone.
yeah, monotone, one tone. So again, always looking at those 3 steps. I know I can't take out anything in common between all of them. Okay, so I need to go to that Psf method, which is slightly different. I'm looking for the product between the first and last now. So 2 times 5, which is just 10. My sum is just the one in the middle. Be careful because there can be negatives. Okay. So now I'm thinking, okay, because I've got a sum of a negative, I'm going to have negative numbers involved. But I'm also saying, hey, I've got a product which is positive. So how is that possible? Yeah, I'm probably going to have 2 negative numbers, aren't I? So think about the factors of 10, or there's just 1 and 10 really. But if I want the negative versions, I actually want -1 and -10, right? Let me just check them. If I multiply them together, negative times a negative is a positive. If I add them together, -10 minus 1 is just -11. So that checks out. After I've got those factors, then I want to break up that middle term into whatever those factors are. Plus 5. Okay. Now for this one, sometimes with the negatives, it does get a little bit tricky with trying to see what's in common. This first one's pretty straightforward. What's in common with this first pair? 2x. So I take that 2x out. I'll get left with x minus 5. When you look at this one, okay, you're thinking that 1's in common. But remember, with the grouping in pairs method, I actually want this x minus 5 here as well, don't I? So I can actually take it out at the end. Yeah, so instead, let's take out a factor of -1. If you divide this by -1, you just get left with positive x. And in this one, you get left with -5. Okay? And that's how you can get x minus 5's there. If you just took out a factor of 1, you get something different in that bracket. You wouldn't be able to factorize it out because it's not in common between both terms. Okay? So that's where you want to be careful with how you're looking for what's in common. And then just the last step, you factorize the x minus 5 out. And so you get 2x minus 1, x minus 5.
Do you have to swap it?
You don't have to. I'm just letting you know in the answers they'll probably have it like that. So don't be confused or anything. Alright, our last example with a non-monic trinomial. I've got this expression here. I want to put into 2 brackets. I'm already thinking, okay, because it's not monic, is there anything in common that I can take out? Okay, there isn't. Then I need to use my revised Psf method. So I'm looking for the products of the first and last. So that's 3 times 6, which is 18. Then you need to sum to the middle. It's 11. And so again, I'm just going to go through all my factors. 1 and 18 don't work. 2 and 9, well, they do work, right? And when I have this, I want to break up my middle term into these two factors here. I'm not going to change it at all, but I'm just going to break up 11x into 2x plus 9x. Okay? And then I want to start looking for what's in common between my two pairs. Because I've got four terms there, I'm thinking of my grouping in pairs method. So what's in common here? Well, there's an x, factor of x there. And that looks like all that's in common, right? So it should be 3x plus 2. And I look for what's in common between these guys. I can only see a factor of 3 there that's in common. So I'll just take that factor out. 3 outside of, I get left with, oh, that's convenient, 3x plus 2. And then, once you write that out, you'll notice that you've got a common factor of 3x plus 2 of all of those. So you can just take that factor out, get 3x plus 2 outside of x plus 3. That's it. Non-monic factorization of trinomials there.